This is 7.2, angle relationships in quadrilaterals. So many quadrilaterals are visible in this photograph of the recent addition to the Ontario College of Art and Design. Quadrilaterals are important shapes in design and construction. Quadrilateral shapes appear in both ordinary and unusual new buildings, as well as in everyday objects all around you. So let's look at the investigate method 1. Use a pencil and paper. Draw a large quadrilateral. Label the vertices. First of all, what's a quadrilateral? I don't see a definition here. Who knows what it is? Henry.
It's like any closed line segments that have 4 sides.
Good. So kind of a 4-sided shape, pretty much. Yeah. Draw a large quadrilateral. Label the vertices. So here's our quadrilateral with 4 vertices. Use a protractor to measure each of the 4 interior angles. Find the sum of the 4 interior angles. The sum of the 4 interior angles are, Matthew? 360 degrees. Thank you. Compare your results with your classmates. Stephen, the sum of your interior angles?
360.
Good. And Alvin, you got? For the sum of the interior angles of your quadrilateral? Nice. We're all the same. All right. Perfect. Make a hypothesis about the sum of the interior angles of any quadrilateral. Nicholas, what do you think?
Repeat the question.
Really?
Yeah.
He got 360. He got 360. He got 360. What's your hypothesis?
He got 370. It's 180.
All the angles. Yes, 360. Any quadrilateral can be divided into 2 triangles by constructing a diagonal line AC. How are the angles in the 2 triangles related to the interior angles of the quadrilateral? So how are, yes?
If we know that one triangle has an interior degree of 180 and there's 2, so that means it's going to be double, so 360 total.
Yes, that's right. Yes. So if this triangle has an interior angle is 180, this triangle has 180, we know that the total is 360. Yes. Explain how you can show that the sum of the interior angles is the same for all quadrilaterals. I think we've exhausted that point. Yes, we've done it. Extend one side at each vertex of your quadrilateral to create an exterior angle. Name and measure the 4 exterior angles. Find the sum of these exterior angles. So we extend them here, we can see. And then we have these angles. Make a hypothesis about the sum of the exterior angles of any quadrilateral group. Describe how you can test your hypothesis. What do you guys think it will be? The sum of the exterior angles. Max?
I think it'll be 360.
360? Okay. And Max is correct. As we can see in the key concepts, our exterior angles add up to 360. Our interior angles also add up to 360. Okay? Just wanted to double check there. All right, method 2, we're going to try and see if we can squeeze that in tomorrow. That will take us, graphing calculator we definitely won't need, to example 1. Find the measure of the unknown angle in each quadrilateral. So x here, we're going to take 360, we know, is the sum of the interior angles, and just minus each one of these. Okay? So that's what we're doing here. 360 is equal to the sum of all the interior angles, 360 minus all of the other interior angles, 249. We get x equals 111. In this question, we're asked to find the unknown angle in each quadrilateral. So in this one, they're asking us to find y over here. Okay? We know the sum of all exterior angles equals 360. Therefore, we have 3 exterior angles, so we need to subtract these 3 from 360. Again, same pattern, 360 minus 243. Y is equal to 117. Any questions so far? No? All right, example 2. 3 new definitions. Exciting. Use this diagram to determine 2 of the angle properties of a parallelogram. All right, so there's our parallelogram. Angle properties of a parallelogram. So we can see this diagram. We can see a few things in common here. Notice this, if I were to extend these lines here. Okay, that's what they do here. The interior angles of a parallelogram here, these interior angles, this we call this the C pattern because it looks like a C. They add up to 180. Okay, do you guys see that C pattern?
Yeah, wasn't this
Sorry?
wasn't like when we had to like apply for that for MSQ, you had like it was like a booklet that you do.
Yeah.
That was one of the things I think.
Okay, so there are a few patterns, right? There's the C pattern here. There's Z and there's F, right? So there's C. F would be like this, so I draw an F like this, and this pattern down here. So call this angle C. So A plus C is 180. Sorry? Oh, sorry, yeah, these two angles are the same. A equals C, my bad. And then Z pattern, so again, two parallel lines like this. You have a Z pattern here. X is going to be equal to Y. So kind of the nook of the Z. Let's draw it a little bigger up here. Okay, so in this Z pattern here, inside the corners of the Z, X is equal to Y. Alright? Likewise, this angle here, A and B would be the same on the outside of the Z. Okay? And finally, there is, sorry, we did F, C, and Z. There is opposite angle theorem. Okay, so Y is equal to X and O equal to H. Okay, opposite angle parallel line theorem. So examining the measures of the interior angles of this parallelogram shows that adjacent angles are supplementary. Angles at opposite vertices are equal. You can show these relationships apply to all parallelograms where a transversal crosses two parallel lines. Angles that forms a C pattern are supplementary. So the two interior angles of the C add up to 180. The two angles below the lines that form the F are equal. So adjacent means adjoining or next to, supplementary means adding to 180, and transversal, the line intersecting two or more lines. It's transversing two or more lines. Finally, we'll read this last part. In any parallelogram ABCD, A is a transversal between the parallel sides AB and CD. So AD is a transversal between the parallel sides AB and CD. This line connects these two lines. CDA plus DAB. CDA, this angle, plus DAB, this angle, is equal to 180. So that's the C pattern. All right? A and D, A plus D is equal to 180. Any questions on that pattern? Applying the same reasoning to each side gives this. So this is the C pattern on all four sides. This angle leads to a relationship between opposite angles. So we know that relationship between opposite angles in a parallelogram, they are the same. Here and here. Therefore, opposite angles in a parallelogram are equal. So finally, our key concepts The sum of interior angles of a quadrilateral is 360. The sum of exterior angles of a quadrilateral is also 360. Any questions? Very easy, very similar to 7.1, just dealing with quadrilaterals.